What's up, ladies and gentlemen, YouTube, everybody out there, it's Philip20, and I'm back. Check this out. This is an old microwave. We're going to make a transformer for charging batteries or whatever you wanted to do with the 1.64 volt transformer. It really doesn't matter to me what you want to do. What matters to me is I get a lot of amps and it will provide 1.64 volts on the batteries. So I want to get a near constant current for these individual cells. I want to be able to make my own battery charger because I don't want to pay $400 or $500 for a battery charger. So I found a free garbage microwave that's been in the rain, and we're going to take it apart. I've already took the liberty of getting the screws off of it for you. Now, if we get a closer look, we've got some stuff here. You got a magnetron transformer. Here's a capacitor. This capacitor is swollen. It's probably what's wrong with this microwave in the first place. I'd say the reason why this microwave quit was this capacitor. So we've got this thing. This is called the transformer. It has two coils. Primary coil winding, which is the 115 volts. Secondary coil winding, which is the 2,000 or 3,000 volts. If you can get a closer look, it's got these lines here. So this line here. So what you're going to do is you want to cut the weld off with some type of grinding tool here. Yeah. So, ladies and gentlemen, what I've done is I took the cover off of this, and now we've got these two coils. If I can get out, it looks to me like they're both lined in at the same time. So I got an idea. So here's our coil. It's solid copper. And then we got this other one we got to get out too. I'll have to re-weld some of this back together. Here's another coil. This appears to be like the low voltage higher amperage coil. I'm not sure how many amps this would handle, but this is a coil that I could possibly use in it with without disassembly of it. And right here is the secondary coil. This sucker, it smells kind of burned, but it doesn't look black, so I'm assuming it works. These things always smell bad. So we've got our iron core. Now, there's two ways to do this. Now I'm thinking about doing it to where the cores are, you know, like this, opposing each other. And then I just put this coil in there the way it is. Now, to properly do this, you're going to want to attach a white wire to a screw to here. And the reason why you're going to want to do that is in case this coil goes bad and touches this piece of metal here, you won't get shocked whenever it does. But I'm just going to test it, and remember, this table is conductive, so I won't touch the table directly. I'm just going to test the transformer on the top by plugging it directly into an extension cord. So you got white on one side, pretty loud. That sucker is really loud. I think I'm going to weld the top and the bottom together. So, ladies and gentlemen, I welded this all together. And I put this coil in here, okay, and this 3-turn coil, and that puts out 0.8 volts right here, and if I shorted it together, it would glow red almost instantaneously. So the amount of energy that could be outputted with this one is a whole lot. We got a drawback though. This coil is drawing 50 amps for it to be turned on at 115 volts. So what we've got now is a transformer that's going to trip the breaker basically nearly every time you plug it in. I was able to draw some currents real quick, and it's drawing 50 amps out of this coil, and I believe that's because the magnetic core is not here in this empty space, because it don't draw 50 amps when it's plugged into the wall as a microwave. Now I'm assuming that it's directly connected to 115 volts when it's energizing this transformer, because it takes a lot of power, and therefore it shouldn't have any resistor in between this and the power coming in from the house. So I'm going to take and cut these 2 spot welds off. I'm going to flip this over, I'm going to slide it up, and I'm going to take and put the iron core back on top of it the way it originally was. Ladies and gentlemen, I think we've come to a conclusion. Is this coil has mass inside of it, and it's important to have it the full amount in there, because if you don't, then it'll draw a whole lot of amps. And let's see what the amp draw is here. 12.9 amps, which is perfectly safe for us to run, etc. Now, drawback, I don't know the voltage yet. So I'm going to test the voltage here. Now we can get a picture of the voltage. Right now the voltage is pretty much 0. Lay that to the side. Alright, so 3 turns all the way around is 3 volts. Okay, so we got a 3-volt transformer right here from 120 to 3 volts. If you short circuited this, they'd probably be like, 1,000 amps run through it, so it'd melt immediately. It would like just blow up in a huge amount of fire. It'd be pretty cool, but it's not pretty beneficial. So I've got to make an on-off switch for the transformer, thermal limit for the transformer. I'm going to put a thermal limit on this thing. Whenever this coil itself gets hot, it turns off, etc. So this is really nice so far to have this kind of transformer. It's a pretty good size one, pretty heavy, and right now it works, and it'll charge batteries, but I got to make it a lot quieter. This thing is loud as you know what. So what I'll have to do is to reduce the amount of power, reduce the amount of turns in the transformer. Now let's test it again. We want to get to 1.64 or slightly above it. power 4. We're going to take some of this turn out once again. So, we'll keep taking some out and then we'll know exactly how many turns our big wire is going to need for the project. Now, we can keep testing. Oopsie. So we have done less turns than we need to. This 1.9 volts is going to be 2 full turns. So whatever wire I fit in here, it just needs to be 2 turns. And with that 2 turns, I'm going to have an enormous amount of amps. Probably, yeah, I'll probably be able to put out 600, 700, 800 amps easily. So that's pretty cool, I guess. 1.9 volt transformer from 115 volts. The amperage is pretty high. 2 turns is what you'll need. You've seen it with your own 2 eyes here. Ladies and gentlemen, we got a near finished project. This was a pain in the butt to get this in there, but I got it in there. And this is 4-aught cable. This is not even considered wire anymore, it's considered cable. It's got pretty flexible copper connection, 2 of them. And the amps that can go through this exceed how many amps my clamp meter can register. It goes over the limit. So, you know, it's totally safe to touch. These 2, I got 2 turns in here. It's kind of weird, but I really have 2 turns. So 1, 2. We've got 2 turns. I don't have to worry about this wire getting too hot, at least not the top one. The bottom one, it'll probably get pretty warm. I didn't expect I would be able to get 2 turns in here, but I was luckily able to. Think I'll weld this plate on there, and then I'll have a 2-volt transformer. So, ladies and gentlemen, this is now my transformer. It is quiet, it's usable, it draws about 15 amps. So there's a drawback with this device. I will have to submerge this in oil to prevent it from being overheated. I have to put it in a bucket of oil whenever I use it, and I have to maintain the temperatures of that oil during the operation. This thing actually, now after everything's said and done, with the amp meter on the 115 volt circuit, we pull around, let's see, 14.6, 14.4 amps. When I touch it together, it goes up quite a bit. So there you have it. It pulls about 17 to 30 amps short circuited. This thing is a monster. That's what I'm talking about. I set out to make a transformer that can put out a lot of amps, and I did. Now will I be able to use all the amps? No way. no possible way I can use all the amps on this transformer. But if I'm going to be using it to charge batteries, I'm going to super glue heat sink on it. I'm going to dip it in oil. I'll probably put another heat sink on the other side, and it'll sit there in oil and absorb the heat from the iron core. Hopefully that'll be enough to keep the windings cool enough to operate indefinitely. I'll be able to charge those NiCad batteries on a ridiculously high amperage charge. This thing's going to be about, let's check the voltage. I haven't done that, so let's go ahead and do that now. The voltage on this guy, monster, what is your voltage? It's 2.222 volts, which is plenty enough for me to operate this transformer. I'm really happy already. I've made an awesome, copper melting machine. This is melted that color. Look at that piece of copper. It just melted together. There's more on this side too. So, yeah, I'm pretty happy. I hope you guys liked the video. Like, subscribe, share, comment. If you like this video, there'll probably be a lot more videos coming out similar to this. This is not totally finished. I've got to put it in a bucket of oil and stuff like that. You guys are going to see the upcoming finished project from this. Hello, ladies and gentlemen. Thanks for watching all the way to the end of the video. There's lots more content coming. Click the subscribe button below. Make sure you come back for more, because there's great content always coming up every day in this channel. See you next time. Peace.